Okay, cool. Thank you, everyone. It's a pleasure to be here. It's actually my first FrOSCon. I've been a FOSDEM dweller for the last, I don't know, 10 plus years, but this looks like an amazing event as well, so I think I will frequent it more often. So my name is Peter Farkas. I am from a country what Germans would call Ungarn, but I'm actually living all over the place. My background, I have about 20 years of experience with various different open source technologies. My entire career is basically about open source and mainly around databases. I've worked at companies like Percona, Cloudera, and now I'm CEO and co-founder of FerretDB. So hands up if you've heard about FerretDB before. Okay, so quite a lot of people. That's great. How many of you are MongoDB users? I'm sorry. I'm sorry. Oh my God. Any Postgres users? Okay. Okay. Cool. Then we are a Postgres crowd here. Okay. Awesome. I'm just going to tweak my talk a bit based on that information. So who are those with MongoDB and Postgres workloads? Okay, well, you came to the right place. So this presentation is not really going to be a sales presentation, not really going to be a presentation about how awesome FerretDB is. I'm not trying to sell you anything except for some advice and some idea on what to do if you happen to be running MongoDB workloads or if you're a Postgres enthusiast. So first of all, I'm going to talk about why do we care. So why would you want to move MongoDB workloads to Postgres? That's about the stupidest idea you would probably hear at the first glance. MongoDB is MongoDB, Postgres is Postgres, and why would anyone use MongoDB anyway? Especially if you have a Postgres background. There's JSON, there's whatever else you have in Postgres, and just call it a day. Well, it's not that simple, and I'm going to talk a bit about that. Then I'm going to talk about or bash MongoDB's licensing. Then we will go through the history of SQL as an open standard, and I promise that this is going to make sense to do. Then the MongoDB query language and whether that should be an open standard, the architecture of FerretDB or how we solve these certain problems we are going to identify throughout this presentation, and then we will have a conclusion. So let's dig right in. This graph is the Stack Exchange Developer Survey of 2024. And there was this survey, or there's this survey every day on Stack Exchange where they ask developers which database environments do you really want to work with, or which database environments you're already familiar with. And then they compile the results, and that's how we can gauge the popularity of various different database technologies. So as you can see, and to the pleasure of the Postgres crowd here, Postgres is the most popular relational database and, well, most popular database among developers. And then there's MySQL, which had the throne for a lot of years, actually. SQLite running on all of our phones or embedded devices or beyond nowadays. And then there's MongoDB and Microsoft SQL Server. So there is an outlier on this graph, but if you have read the title of the talk, then I think you can guess which one is the outlier. It's MongoDB. But why? So why is MongoDB an outlier on this graph? Any ideas? Yes, that's the only web scale database. Good. Yes, it's the only document database, and it's also not open source. So if you look at the relational database arena here, you have lots of choices. You have Postgres, you have MySQL, you have SQLite if you want to stay in open source, or you can also use Microsoft SQL Server if you have a reason to do that. There are reasons to do that, so I'm not going to bash on Microsoft here or talk crap about Microsoft users. There are certain environments where it makes sense to use Microsoft SQL Server. However, if you're with MongoDB, you're pretty much screwed. Why? Because that's not open source. It was. You managed to take your bets on or put your bets on open source, and then the rug was pulled from under your feet. So the only document database with a measurable popularity among developers who are maybe not they don't develop software full time, but they want to develop software as part of their job. Especially, they like MongoDB and it's popular among them. So this is the point where maybe not on an open source conference like this, but on many events I delivered a presentation, someone would ask, wait, but isn't MongoDB open source? Well, so it was. MongoDB started out as an open source database software, and until 2018, it was released under the GPL or AGPL license. And then they came out with something else called the SSPL. So the SSPL, the server-side public license, started out to be this revolutionary new open source license. It's going to fix all of the issues of all open source licenses by simply not allowing Amazon or Microsoft or whoever else to run the software as a service. And this is going to fix all of the issues with open source, because evil cloud providers will not be able to leverage open source software for free without contributing back to the community. I mean, on paper, this sounds okay, but the execution failed miserably. I think at this point now we can say that it did fail miserably. So basically the SSPL says that if MongoDB is used as part of a cloud service, then you need to release everything in that stack as SSPL, or you need to pay a license fee to MongoDB. So essentially, if you provide a service where the database is MongoDB on the backend, then you might violate the SSPL license if you run it as a service. How do you know? How do we know if we violate the SSPL license? If you read the license, actually you will be lost. Because it says that you violate the license if you don't provide enough added value over MongoDB when you run it as a service. How do you define that? So can I sue you? Or if I change the name of the comments and provide MongoDB but with a different list of comments, do I violate the SSPL? Will I be sued by MongoDB? We don't know. So we actually found this good website, ssplisbad.com. I promise it's not me behind it. I don't know who did that. I'm not sure what the agenda is there, but it's correct. SSPL is bad, and it tells you why. But before I go forward, so why is it bad that we don't allow anyone to run MongoDB as a service? So only those who pay the license fee can do that. I mean, theoretically, from an open source perspective, it's good because developers are going to be paid, the company behind the software will be paid. So what's the problem with that? Well, the problem is that if you don't allow anyone to provide open source software as a service, then that means that there will be only a handful of options on the market who will be able to do so. So MongoDB's situation led to only a handful of service providers providing MongoDB as a service. For example, MongoDB Atlas or DigitalOcean. or Amazon or Microsoft. And I think the list is pretty much over. I mean, there's not much else out there. What does it mean to users, to you? You're not the evil Amazon. You thought that the license is not going to be against you, but you're going to have to pay more because there's zero competition on the market. So if there's no competition on the market, if MongoDB can cherry pick who they give licenses to, then you, the user, are going to be on the losing end of all of this ordeal. And this is why I'm here today, and this is why we care about what is happening with MongoDB. So Postgres people, why don't we just use Postgres and JSON? Why do we need MongoDB? After all, MongoDB is not well liked among database enthusiasts. I think we can say that it's not the darling of those who really understand database internals. It's not really something you want to geek about, but it's definitely popular. So what's the reason? Well, the reason is that MongoDB was able to solve something which other database products couldn't, and that is ease of use. I mean, we can joke about web scale and all the marketing bullshit MongoDB came up with over the years, but what they did right was training, resources, ease of use, the ability for developers to solve issues inside the code and not in the database, meaning that they could get into the habit of not having to dig into database topics. They could just solve all of their issues within the frameworks they are comfortable with, such as the JavaScript frameworks they are using, or whatever else that aids their development work. So MongoDB allows developers to stay out of the database world, and they gladly took the opportunity to not have to dig into Postgres. And so whenever I say this, and I'm sure that some of you might think, okay, but what's wrong with SQL? What's wrong with whatever we have in the relational database world? Why is it so complicated? Why do we need yet another sort of abstraction layer over databases to succeed here? So let me go through the short story of SQL so you might understand what is happening with MongoDB users and on the market in general. This is not going to be a historically accurate representation of the history of SQL, of course, because we don't have enough time to go over all of the intricate details, but I'm going to do my best to not mislead you, actually, with my concise presentation here. So the short history of SQL started with this person called Edgar Codd, who worked in the IBM research labs in San Jose. And he is the person who invented the relational model. So he is the reason why we are thinking along the lines of tables and indexes and anything you can think of in the relational model is derived from the work he did at IBM. And the reason why the relational data model was needed is because the date is 1970. So obviously there was a huge leap in terms of the advanced hardware. IBM was coming out with digital computing and related services were on the rise, and we needed something which does a better job than the previous approaches to data storage. So he published his paper, but there was one problem with Edgar Codd's approach to the relational model, or towards the relational model, and that was insanely hard to use it. So it was insanely hard to query data, to insert data, because you practically had to come up with a separate program for the computer to actually do what you would do with SQL nowadays. So for the end user, or even for developers at the time, the relational model was not palatable. It was not something developers or users wanted to love. And the emphasis was on end users, where some of these computers were used by ordinary people at companies and government offices, and you couldn't expect them to get on the same level as Edgar Codd, who was a mathematician and who was very well versed in computing. So Don Chamberlain and Ray Boyce came to the rescue. These are the two individuals who saw a lot of opportunity in the relational model, and they came up with a solution where it's no longer needed to write code to query or insert data to the relational database, but they came up with SQL. And the point of SQL was to invent a language which is almost like the English language. And so those who are not as advanced in computing will be able to use the database software. So SQL was this abstraction layer which enabled ordinary users to still be able to work with databases or with relational databases. And I think this paper was published maybe in 1974. And a sour fact is that after publishing the paper, Ray Boyce actually died due to brain aneurysm. He was not even 30 years old, so he never lived through the immense advancements of what was enabled with SQL in database technology. But Don Chamberlain, I think he's still doing well, at least the last time I checked. And well, this is something which we can all be thankful for. However, they all worked at IBM. Like, that's one company, that's one big blue company, and they want to make money, right? And they did. So IBM was pretty much the only go-to place for you to get hardware, to get computers at the time, especially at a massive scale. So they released multiple relational database products, and they supported SQL. So if you were a user and you wanted to use SQL and you wanted to use the relational concept together, then there was no other option for you but to get an IBM computer. And you couldn't really get these things. You needed to lease them. So you pretty much had to get this washing machine or multiple washing machine-sized boxes in your office, and that was the only way for you to use SQL, and it was not even yours, it was someone else's computer. And if you didn't like the lease agreement, if you didn't like the size of the computer, if you didn't like IBM, then, well, you were out of luck. You couldn't use SQL and you couldn't use the relational model. So what happened? At the end of the 70s, but pretty much early 80s, lots of alternatives appeared for relational database products, or IBM DB2 alternatives. Informix, Sybase, or a company called Relational Software Systems Incorporated, which was really Oracle, which started under a different name. And these companies pledged that they are going to save users from the vendor lock-in situation by implementing the relational model and by implementing SQL or something like SQL to go with that. It's very difficult to believe that Oracle once was seen as the savior who saved you from vendor lock-in and who solved your IBM problems. But it was true. Oracle was really seen as the company which enabled you to use databases outside of the realms of IBM and maybe even on computers which were not IBM compatible. Strange times. However, so all of these companies and many more implemented SQL, but what is SQL? It was not a standard. It was pretty much, whatever idea they had about how SQL should work. Sometimes they improved SQL over IBM. Other times they did not develop all the features, meaning that they were largely not compatible with each other. So there were many different dialects of SQL, but there was no conformity between these products or the implementation of SQL. And then in 1986, SQL became an open standard. So the industry pushed, users pushed these companies to come together, form a standardization committee, decide how SQL should look like, and that's how we arrived to the point where all vendors were, of course, proprietary, Informix or IBM or whatever. So open source was not really a thing back then. But at least SQL was implemented sort of the same way across all of these different products, or they had a chance to do that. But that was still vendor lock-in. And in the mid-90s and early 2000s, that's when the real revolution happened thanks to the SQL standard, because Postgres, MySQL, SQLite, and many other products implemented the relational model and implemented SQL as an interface to interact with the relational database. And that's what fueled the immense amount of innovation we see in the database world today, where there are hundreds of derivatives of the same idea as what Edgar Code came up with in the 70s. And we could argue that it was a much easier to use thing than many of the alternatives were. So why am I talking about SQL here? Because after all, we are not in the 70s anymore. We don't have to buy a washing machine-sized computer to have in our homes to fiddle with databases. We are not dealing with the ancient history here. We have AI, we have web scale, we have Bitcoin, we have everything we need. Well, not really, because let's look at document databases. So just to use what you've learned or already knew as to put something in parallel with what is happening with document databases at the moment. So MongoDB says, okay, these relational databases suck. Why? Because they are hard to use. I mean, who wants to learn this complicated SQL? This is a horrible idea. This is like, whatever happens here, sometimes your queries are like this, and who wants to learn all of that? After all, we are JavaScript developers. We can just put all of our database logic and structure into JavaScript, and then there will be a database which handles all the rest, and it will auto scale, and it will be, nice. You will not need to be a database administrator to run a database. With these promises, they're pretty much the same promises as what SQL started with. It achieved market dominance in the document database segment. It actually popularized the document data model to the point where ordinary developers or not even developers knew what document database were, and MongoDB pretty much became this strong brand name. And after they realized that they are popular enough, that they used open source enough to achieve market dominance, they grabbed the rug and pulled hard and pretty much pulled the rug from under all of their users by saying, well, we know you like this open source thing, but now we need to defend ourselves from the evil Amazon or the evil Microsoft, and this is going to be good for you. So that's when they changed over to the SSPL license, and they claimed that this is still open source. And in fact, to this day, we were sued by MongoDB, or we were sent a cease and desist letter as well, stating that SSPL is open source. So why do we say it's not? Well, no one else says it's open source, it's only MongoDB. But that doesn't distract them from sending us letters. So if you remember the slide where we were talking about SQL and its alternatives and all that, so after the license change, lots of companies realized, oh well, we can't use MongoDB anymore because we are not allowed to, because we violate the SSPL, or we may violate the SSPL, we don't know. So let's implement alternatives. That's awfully similar to what happened when IBM came out with the same thing. When IBM did the vendor lock-in and others realized that alternatives are needed. Let's implement the MongoDB query language across different platforms like Amazon, Huawei, Azure, Cosmos DB, or even Oracle. Strangely enough, Oracle came to the rescue of open source users by allowing MongoDB applications to interact with Oracle databases. I mean, good on them, that they absolutely should have done that, but strange times. So all of these are nice, they are great products, but the problem is the same with them as the problem was with relational database or IBM DB2 alternatives, and that is that they are all proprietary, they look similar, but they are incompatible with each other, and believe it or not, you need to lease someone else's computer to use them. I'm not kidding. If you go to Amazon, you know, well, the washing machine is not in your office anymore, but it's still a washing machine somewhere. And if you don't like the terms, or if you don't like the thought of a washing machine somewhere, or your data on it, tough luck, you don't have a MongoDB alternative. So once you choose one of these, you might be stuck with that. So to summarize, the issue with MongoDB alternatives is that they might have a different feature set across them. There's a different degree of compatibility. Therefore, migration is pretty hard, and they are mostly tied to cloud vendors. But the most important problem is the moment you create an alternative to Photoshop, you create an alternative to MongoDB, you create an alternative to Oracle or IBM DB2. If you're a Postgres database administrator, someone wants to migrate from Oracle, and you say Postgres is an Oracle alternative, it's a good alternative. Well, you will find that the features are just not there sometimes. The user is used to doing things what you don't have in Postgres. So you can't really call Postgres an alternative to Oracle unless you rewrite the application. Meaning that as long as you call yourself an alternative to something, you need to listen to what the original development team is doing. You need to follow the new features and the deprecated one to stay compatible. So as long as you're called an alternative, the original author sets the pace, and that's unsustainable. So what should happen? So my point here is that we are in need of a new open standard for document databases, pretty much an open standard which is a standardized core feature set derived from MongoDB, the same way as how IBM DB2's core feature set was made part of the SQL standard. It would be a JSON-like query language. It could be extended by different vendors, the same way as MariaDB does with MySQL or Percona or many of the database as a service vendors, which would ensure portability between products. It would stimulate innovation the same way as what happened with SQL. And it would be very good for users. So I think that if there would be an open standard for document databases, then we would see the same kind of explosion on the document database market and among the possibilities for document database users than what we have seen with SQL back then. So what were the steps taken so far? What did we do? And what's the current progress? So FerretDB is a MongoDB compatibility layer which is written in Go. And it pretty much turns Postgres into a MongoDB compatible database. So at FerretDB 1x and 2x, we have this layer on top of Postgres, and with 2x we also have a Postgres extension which implements some of the MongoDB feature set, meaning that if you have a Postgres instance, you put FerretDB on top of it, and then your MongoDB applications can connect to it, and they will not know that they are not running on MongoDB anymore. So just to demonstrate this very quickly, well, it will not be a spectacular demonstration, but I wanted you to see this. Hopefully, well, it's not going to work. Okay, let me start Docker in the background in the meanwhile. Sorry about that. So basically, your application that needs MongoDB will not know that underneath your database infrastructure there's Postgres. And that's a powerful tool in anyone's hand who implemented MongoDB or went with MongoDB and now needs an open source alternative. MongoDB compatibility means that existing elements of the MongoDB ecosystem, such as what you use to do administrative stuff on the database, or if you have a framework, they are able to interface with FerretDB without having to rewrite some of your application or all of your application in the process. That means that there's no cliff to climb when a migration needs to happen. For example, and I think now it should work. So for example, if I connect to this database, this is MongoDB Compass. It just updated to the latest version, so hopefully we are still okay here. And then I give a JSON file and import it. So this was successful. I imported a bunch of books into MongoDB based on the opinion of MongoDB Compass. But if I look at connection info, it says that this is MongoDB 7.x community edition, while in the meanwhile, it's actually FerretDB, which is Postgres and FerretDB together. So that means that your application will not know that it is not running on MongoDB proper, that That means that you don't have to rewrite your application. Compatibility is not 100% exactly because it's not possible to add all of the features or all of the elements here. But the goal is to work with at least 85% of MongoDB workloads. And how we did this is that if you look at the MongoDB situation, so the MongoDB drivers are Apache 2.0. They are still released as open source, and then they interface with the MongoDB API and the WireTiger database engine, which MongoDB acquired. That's how they became actually performant and stable. And that is under the SSPL license. And what FerretDB does is we take MongoDB, the MongoDB drivers, which you have in your application. You have FerretDB interfacing with it, and then FerretDB stores Postgres source data in Postgres, meaning that your entire stack is going to be licensed either with the Postgres license or the Apache 2.0 license. Another good thing about doing this is that I mentioned earlier, if there's no competition on the market for your MongoDB needs, and there's no real competition today on the MongoDB market because it's really just MongoDB and their friends, you're going to pay more. But with a solution like this, you can actually turn any Postgres as a service provider into a MongoDB as a service provider with the added compatibility that FerretDB adds to MongoDB. So again, the compatibility is not going to be 100%, but there is a high chance that your workload will run just fine on a compatible solution. And now about the big scary cloud providers. So I noted earlier that the more alternatives you have, the more incompatibility you're seeing because there's no real open standard or standard for the implementation. Well, after 2 years of working at FerretDB, Microsoft actually reached out to us and said, well, we spent lots of money on creating an alternative to MongoDB, which runs on Azure, but we like what you're doing. So what they did is, well, we worked together to release FerretDB 2.0, which essentially got Azure Cosmos DB's engine, which means that Azure Cosmos DB for MongoDB and FerretDB are pretty much very similar in terms of feature set, meaning that there's one less incompatible alternative on the market. That is a step towards standardization, because if there are less difference between the alternatives, the better it is for the users. So FerretDB 2.x is largely compatible with Azure Cosmos DB for MongoDB because it relies on the same Postgres extension as what Microsoft runs in the cloud. But we also have this awesome initiative called OpenDocDB.org. So OpenDocDB is a community-led push for standardization for an open standard for document databases. We released the compatibility test suite. So if you have a MongoDB alternative, you can compare them in terms of how compatible are they with each other. Therefore, we want to certify compatibility. Let's say Cosmos DB for MongoDB is 27% or 55% compatible with AWS Document DB or the like. And using this data, we would like to come together and write a standard together, the same as what happened with SQL back then. And this is supported by many companies in the Postgres community. So if you look at the website, we do have some interested parties, and all of the cloud providers expressed their interest as well. So I think that there will be the same or very similar push towards standardization in the document database market, as it happened with SQL. And this is why I took some time to talk about the history of SQL. Conclusion here. So the conclusion is that there is a need for an open standard for document databases, to push for innovation, to get it back to open source, to have the same type of innovation as what MySQL or Postgres or SQLite or the rest created in the relational database space. We think that MongoDB is going to be the same kind of commodity as SQL is, that it could be used anywhere you want. And we also think that the two technologies will converge more towards each other. So it's likely that SQL is going to get some document database features and vice versa. When it comes to FerretDB, we do strive to lead the way in opening up the document database market. We do build FerretDB with the community. We have lots of contributors. I would really like for you to look at our GitHub. We are proud to have more than 10K stars there, which is the ultimate sign of success, of course. There's nothing else, no other metric here. And I also want to direct your attention to an upcoming update here. If you would like to follow the FerretDB LinkedIn or my LinkedIn page. So we were actually sued by MongoDB for doing all of this. So they don't like the fact that there are compatible alternatives on the market. They do think that only MongoDB can be compatible with MongoDB, and we all know that this is not the case. So if you're interested in some open source drama, then I direct your attention to these LinkedIn pages as well. With that, thank you so much, and let me know if you have any questions. So your question was, why didn't the community fork MongoDB when the license change happened, when the code was still, fresh? That's a very good question, and we've been wondering about that for years. In fact, we started FerretDB at 2021, and the license change happened in 2018. And we were eager to see, starting 2018, whether anyone is going to fork the MongoDB source code. And we believe that it did not happen because there was no strong community around MongoDB at the time. So if you look at the likes of HashiCorp or Redis, where license changes happened, or Elastic, there were forks and there were alternatives the minute the license change happened. With MongoDB, we actually have an interview with MongoDB CEO on one of the newspapers, and it's very easily Googleable if you search for MongoDB open source and marketing or something like that. So MongoDB said, and the MongoDB CEO stated, that open source for them was just a marketing tool. So they never really strived to have a strong community of developers around MongoDB. Probably, well, first because they were not interested in open source, and second, maybe the danger of getting forked is lower that way. But good question. I don't think we will ever really know. Please.
I would like to add that prior to 2018, MongoDB was dually licensed, and it was really expensive to use it professionally.
Sorry, I didn't hear.
MongoDB was dually licensed before 2018, and it was really very expensive to use it professionally.
Yes, it's true. So MongoDB's license has never been the most popular, or their licensing was never the most popular. But that situation was probably a lot more clearer, if you will, since no one stated that AGPL is not open source, for example, or in the current situation with the SSPL license, the really hard part of what happened, or the really sad part of what happened with MongoDB here, is that when they changed the license, they really attempted to redefine open source. They made themselves a victim, and they stated that, well, we can't continue to prosper as a business with open source having these problems, like open source as a whole. So, we all failed here, and open source is crap because MongoDB couldn't do what they wanted to do. And they stated that SSPL is the next chapter in open source and should be an open source license. And that created a lot of confusion among developers, because if you think about it, you're sitting at school and you learn about MongoDB and you look at their training materials. You're, 17 years old, and MongoDB's training material says that MongoDB is a popular open source database, but it does not come with the same freedoms as open source. Then there will be a generation who thinks that open source, with the limitations of not being able to run it anywhere you want, is actually open source when it's not. That's I think what I'm mostly concerned about when it comes to the licensing. But good point though. Please.
You said that there are about 15% incompatibilities between MongoDB and FerretDB. This could be quite a lot if people try a migration. But how come? Do you think that these 15% are nearly impossible to provide in FerretDB? Or do you think that some of the features of MongoDB are just bullshit and you left them out deliberately?
The question of compatibility, of course, comes up most often with an alternative, and I have to clarify. So the difference in compatibility is not 15%. The statement I've made is that 85% of MongoDB workloads will be able to run with FerretDB or pretty much most of the alternatives out there, like AWS Document DB or the others. The amount of missing features between FerretDB and MongoDB is actually way higher. So with FerretDB, I think maybe 40%, 40% of the features are implemented. And the reason behind that, and this is the second part of your question, the why. And the reason is that MongoDB positions itself as a lot more than just a database. So there are features which are not strictly features of a database product, but there are interfaces with several AWS services, for example, or things which you normally need a Postgres extension if you would want to run it on Postgres. The point which we are trying to make is that MongoDB has been a good solution as a document database up until the license change. And this solution should stay a database rather than much more. It shouldn't be this whole development platform, as MongoDB calls their product or called their product. So we don't strive to duplicate or create an alternative to all of the features simply because we don't think that those are needed in a database product, or that those are useful to someone who is looking to store data. I think that the more features you use, and this is true to even open source databases. If you're a hardcore MariaDB user, for example, I mean, I really like MariaDB. I like the MariaDB team, but you need to be cautious with MariaDB in case you use all of their features, because then you're going to stay in MariaDB for a while until you can migrate away from it. And so the more you stick to the bare bones, I think this may be true in any product, even cars or whatever else. The more you stick to the bare bones, the less risk you have for a vendor lock-in situation to happen. So do we want to encourage our users to use as many features as possible, and even the exotic ones, because we are going to endlessly cater to these? Well, we may not have the resources, and we may not even think that it's a good approach. I don't know who was first. Oh, you have the microphone. If you have the microphone, you're king. I mean, we can't dispute the power of the microphone.
Okay, you talked about what you think is going to be the benefit of having an open standard around document databases, and you also pointed out the let's say that you're always catching up if you're not like this leading product that first defined it. So in the case of IBM, that was of SQL, it was IBM, and now with the document bases, it was Mongo. You just pointed out that Mongo offers a lot of platform kind of features that Mongo calls Mongo, but your opinion of what it should be is a smaller set. It's just the database part. So I'm assuming that Mongo is not on board with the open standards initiative. So how? It sounds like a contradiction, right? How is the Open Standards Initiative going to overcome the leading vendor still, being ahead of everybody, basically?
But are they ahead? So is this what we call being ahead? If the question is awesome, and I really like how you put it. So if we assume that MongoDB is a better product because it has a lot more features than just a database, that's fine for us. The SQL standard has been extended with features in Oracle and other vendors, and if you want those features, if you need those specific features as a user, there's nothing wrong with going with Oracle. If you need the AI features of MongoDB or whatever else they have on their development platform, and you're absolutely sure that your life is going to be much easier if you use those features, and there's no way around. Let's suppose you are going to save 2 million euros of your 6 million euro budget. Yeah, go with MongoDB. Don't even look. Probably that's an awesome solution. But most users would not benefit as much other than saving 2 lines of code by using that the feature that is marketed alongside with the database product. So the open standard aims to fix the database problem, aims to create a foundation, and those who implement the standard will have the opportunity to compete with each other, and users will have the opportunity to decide whether they need the features on top of the standard, which increases the risk of vendor lock-in, but it may make sense later on for the user and their strategy.
Thank you for the talk. It's really interesting. You said a lot about the compatibility in terms of features. Do you have comparisons about the efficiency and performance figures between MongoDB and your solution, especially for larger volumes of data and yeah?
Yes, good question. So compatibility is one thing and performance is another. So on the first couple of years, actually, we focused on compatibility, because if we perform but we are not compatible, then no one will be interested in the solution. Now with our partnership with Microsoft, we were able to focus on performance as well, and so the problem actually with measuring performance here is that it really depends on your workload. So in a completely sanitized generic test, we could say that we bring in about 90% of what MongoDB would perform in comparison with FerretDB and MongoDB. But you may have workloads which would perform better, and you would have workloads, or we could identify workloads which prevented much worse, like 10x worse, because of how you queried the database, or because how your application expects MongoDB to behave. So in a certain way, applications are of course developed for MongoDB, and when you migrate, you may find that that is not the best practice for something with a relational database heart inside. And therefore, if you would ask me how performance is different, I would only be able to ask you, well, let's look at your workload, because you might be a very happy camper from day one. You might have to optimize some of your queries, or simply it's a no-go for you to not go with MongoDB, and in that case, that's bad news. That means that you might not have an alternative today. FerretDB is web scale, yes.
Hi. As far as I understood you, the success of MongoDB was largely due to dumbing down interfaces for developers. What do you think, or why do you think ORM systems didn't manage to take that place? There are even ORM systems for MongoDB, so wouldn't that be a better place to achieve the compatibility? Mm-hmm. I mean, right now you're trying to save developers who already went down the rabbit hole, but what about new developers? Or, yeah, mm-hmm. Why do you think the history evolved as?
Good question. So, I think the ORM approach is similarly flawed as the alternative approach, in that there's no standard behind it. So schools, universities, your workplace may not want to invest in something which only exists in one product, such as the ORM or MongoDB itself or whatever else. If everyone is happy to invest in teaching SQL, everyone is happy to invest in relational databases, because we sort of have the understanding that they are here to stay. Existing users are the ones which would benefit from the alternatives for sure. Existing users will be the ones who will benefit from the open standard. But as soon as the open standard gets to the point where it is reasonably popular, then the open standard can start deviating from MongoDB's current approaches, and that's when we can introduce things which would make it even easier to use, or which would make it perform much better, or which would be even more of an abstraction over bare bones databases. It's hard to tell. But back to your question, I do think that the ORM solution would be just a different solution, and it would ultimately not bring benefits over what we are doing now. MongoDB, just a correction here or a clarification, MongoDB did not really dumb down databases. I mean, I wouldn't call it dumb. I would call it different. This child is not dumb. He's just different. But the essence of why MongoDB is, I mean, no one wants to use a dumb thing. Maybe some people would want to use a dumb thing, but the reason why developers use MongoDB is because it pushes all of your problems to the application level. And that's it. If I if I'm successful with JavaScript and my framework in there, then I don't want to learn databases. If someone enables me to not do that, I'm happy. That's what I think developers think about MongoDB. Creating another abstraction layer or another way to do this would add the need to make it popular as well, and to teach people to use it, and it's just a probably viable but not much different approach.
Last question. Okay, you said that FerretDB is also web scale like MongoDB. And
who knows what web scale is? I'm happy to say it's web scale. What is web scale?
From my understanding, web scale means that it can scale horizontally in cluster version. And my question is how FerretDB scales horizontally?
FerretDB scales like Postgres. So you have the scaling problem the same way as you have it in Postgres. So FerretDB is stateless, sort of, meaning that you have a FerretDB instance per database instance, and you can scale these however you want.
I thought, as I know, Postgres isn't easy to scale horizontally. By default, you need some application logic in order to make it scalable horizontally to hundreds of hosts. And my question is whether FerretDB this layer of proxy of FerretDB contains some logic which improves and simplifies this horizontal scalability.
The point-blank answer is there's none. So we don't have anything in FerretDB which would enable you to scale it, simply because most of our users, it's easy to do marketing work saying that, hey, if you need to, you will be able to have it. But frankly, most of our users, most of the users we talk to, or existing MongoDB customers, they just did not have that need. So we concentrated on what was needed. But who knows? I mean, it's not out of the question that it could be done. I'm sure that there is a way to optimize even on the FerretDB level. All right, well, that was the last question, but if you have more, I will be around. Thank you so much for your attention, and have a good rest of the conference.